Hello, my dear student. This is the lecture number 4 on the important chapter, that is the electromagnetic induction. In today's article, you have to study the one important article again. And name of the article, that is the induction and energy transfer. The central idea of this article is that according to Faraday's law, when there is a change in magnetic flux related with the coil, the EMF is induced in that coil, or the induced current is generated in that coil. It means due to the change of magnetic flux, the induction takes place in that coil, and that induction which is produced in that coil, it is responsible for the transfer of energy in the form of heat in that coil. The coil मध्ये जे induction तयार होते, with the help of that induction, the energy get transferred in that coil in the form of heat. This is the central idea of this article. So now let us see here. Here we take the one loop of the conducting wire. Suppose that is the A, B, C, D. And the part of that loop is kept in the constant magnetic field. The part of that loop is kept in the constant magnetic field B. इथे हे सिम्बॉलिकली हे दाखवलेले आहे तुम्ही. This is the magnetic field. And this magnetic field is perpendicular to the plane of the loop. म्हणजे लूपचं जे प्लेन असणार आहे या लूपला हे मॅग्नेटिक फील्ड कसं असणार आहे, that is perpendicular to the plane of the loop and inside the magnetic field direction, that is inside the blackboard or inside the plane of the loop. If you see the magnetic field with this symbol, then it indicates that that magnetic field is in the outward direction, but here that magnetic field is in the inside direction. Okay? First, when you pull this coil towards right by applying the external force with the velocity v, where you pull this coil towards right with the velocity v by applying the external force with the help of our hand. एक कॉइल जर तुम्हाला ते इकडे मूव करायचं असेल, पुल करायचं असेल, उडायचं असेल, तर तुम्हाला काय करावं लागेल, तुमच्या हाताच्या सहाय्याने ती कॉइल इकडे पुल करावी लागेल. It means we apply here external force on that coil. When you do this, at that time, the magnetic field, magnetic flux related with this coil is goes on changing, and according to Faraday's law, the EMF is induced in this loop. The induced current is flowing in this loop. Can you tell me what is the direction of that induced current? It is in the clockwise direction, or it is in the anti-clockwise direction. You know the Lenz's law. The induced current is generated in this loop, and that induced current, that induced EMF opposes which produces heat. मग त्याला कोण तयार करते, त्या कॉइलमधून पास होणारा मॅग्नेटिक फ्लक्स त्या इंड्यूस करंटला तयार करते. आणि ते इंड्यूस करंट काय करते, त्या मॅग्नेटिक फ्लक्सला अपोज करते. मग आता मॅग्नेटिक फ्लक्स इनवर्टला ही कॉइल ज्यावेळेस इकडे जाते, it means that magnetic flux goes on decreasing. या कॉइल से रिलेटेड असलेला, म्हणजे या लूप से रिलेटेड असलेला मॅग्नेटिक फ्लक्स, ही कॉइल जशी इकडे जाणार आहे, काय होणार, that magnetic flux change, but it goes on decreasing. आता ही इंड्यूस करंट काय करणार आहे, त्याला अपोज करणार, डिक्रीज होते. त्या कॉइल मधून पास होणारा मॅग्नेटिक फ्लक्स डिक्रीज होते, तर ही इंड्यूस करंट काय करणार आहे, आता ते त्याला अपोज करणार आहे, म्हणजे वाढलं पाहिजे त्या ठिकाणी. सो इफ यू टेक द डिरेक्शन ऑफ द इंड्यूस करंट हियर, क्लॉकवाइज डिरेक्शन, then according to right hand it is the direction of the magnetic field. The thumb is in the direction of current and the remaining fingers curve around it. बरोबर, करंटच्या दिशेला, आणि थंब कुठे आहे, त्या कंडक्टरवरची कर्व केली, तर मॅग्नेटिक फील्डची डायरेक्शन कुठे असणार आहे, into the line. It means the induced current which is produced here, due to that the magnetic field is produced here. The induced current generates a current flows around it gives the magnetic field, and that magnetic field is in the again into the black hole. हे जे magnetic flux कमी होत होतं त्या induced current ने त्याला अपोज केलेलं आहे. आता magnetic flux अजून magnetic flux क्या डिरेक्शनला दिलेला आहे ते म्हणजे वाढवलेले त्याला अपोज केलं. And this is possible only when you take the current in the clockwise direction here. If you take the direction of the current flowing through this loop in the anti-clockwise direction, then that magnetic field is in the outward direction. हे कमी होते त्याला अपोज केला जातो. So the direction of the finally the direction of the current flowing through here, that is in the clockwise direction. What up to this point? Now see. So when that coil is moved towards right by applying the external force on that coil, the EMF is induced here. Induced here. It means what is done on the loop here. It loop to me इकडे pull करता है. It means what is done on the loop. So the rate of work done, that is P is equal to work upon time. The rate of work done, that is nothing but the power. It is P. So P is equal to work upon time. That is equal to work is nothing but the force into displacement upon this time. Okay. P is equal to force as it is, and displacement upon time it is nothing but the velocity. So finally we write P is equal to F dot V. Here we take the scalar product because power is a scalar quantity and called as equation number 1. Now the magnetic flux with the loop is a loop आहे. या loop से related असणारा magnetic flux किती? That is pi b. What is this mean? या magnetic field चं ते flux आहे. Induced current flow झाल्यानंतर तयार होणारे magnetic field ते नाही. The original magnetic field. So the magnetic flux related with the loop, that is B dot A. Already in the introduction of this chapter we have seen how we determine the magnetic flux. So magnetic flux, that is equal to B dot A, that is equal to BA cos theta. The direction between the B and A, again it is a 0 and cos 0 is 1. So BA cos theta, B, A is area. Now see, the length of this side, suppose it is L, and the length of this side inside the magnetic field, you listen. या कॉइलचा जो भाग magnetic field चार्ज मध्ये त्याची लेंथ किती घेतली आपण x घेतली. So area, that is L into x, which is inside the magnetic field. So B area, that is Lx, called as equation number 2. Now see, as x decreases, it means when you pull this coil towards right, this x goes on decreasing, and as x decreases, it means the magnetic flux related with this coil is also goes on changing, and so EMF is induced in that way. The magnitude of that induced EMF, that is equal to d phi by dt, not minus sign here. Not घेतलं म्हणजे त्याचं magnitude घेतलं. That is equal to d by dt. Put the value of phi from here. That is Vlx, B and L here. That is constant. So take Pl and dx by dt. Again Bl dx upon dt. That is nothing but the velocity. So B and V called as equation number 3. That this is the EMF induced in this loop. EMF induced in this. Now see, suppose EMF is induced, and due to that EMF, the induced current is flowing through this loop. Suppose the resistance of this loop is R. If you see shown here in this, the coil मध्ये तयार होणारे induced EMF E. Due to that induced EMF, induced current is flowing. And suppose the resistance of that loop is R here. So how you calculate the current? The current is nothing but the V upon R. The V is काय येते EMF. EMF is nothing but the voltage. So current I is equal to E upon R. Put the value of E, that is V and V from the previous equation. What is equation number 4? What up to this point? Now see. When this coil is pulled towards right by applying the external force with the help of our hand, the EMF is induced. The induced current is flowing here. The current is flowing to this segment, this segment, this segment, and this segment of the loop. So this is the current carrying conductor. This one is also the current carrying conductor. And you, when the current carrying conductor is kept perpendicular in the magnetic field. समजा हे मॅग्नेटिक फील्ड आहे, या मॅग्नेटिक फील्ड मध्ये हा करंट कॅरी कंडक्टर त्या मॅग्नेटिक फील्डच्या डायरेक्शनला परपेंडिक्युलर आहे. What happened? The force is acting on this current carrying conductor. Already you have seen this in the previous chart. So the force is acting on this side, that is the F. The force is acting on this side, that is the F. No force is acting on this segment because it is not in the magnetic field. This current carrying conductor in this magnetic field, so the force is acting on this. How you obtain the direction of these forces? With the help of right hand palm rule. With the help of right hand palm. काय सांगतो तुम्हाला? There is also one another law, that is the Fleming's left hand rule. All this part you have completed in the previous chapter, that is the magnetic field due to electrical. So right hand palm rule. It gives the direction of the force acting on the current carrying conductor. How? See here. This four finger in the direction of the magnetic field, and this thumb in the direction of the current. When you keep this right hand in this way, at that time, this surface of the palm of the right hand gives the direction of the force acting on that current carrying conductor. See, magnetic field by blackboard. Current is something yes, apply magnetic field direction ला and त्या current direction ला हवा कुठे आलेला आहे वरच्या साईडला. So the force acting here in the upward direction. Again here. ही पुढे पाहिजे magnetic field च्या direction आणि ही पुढे पाहिजे current direction. Current इकडे flow. So thumb is in the direction of current and these four fingers in the direction of magnetic field. So the palm of the right hand in the downward. So the force acting here it is. Now try yourself here. Magnetic current the segment मधून current वरच्या direction of होतो. So the palm of the right hand is towards this. So the force acting here in this direction. Now the force F2 and F3, these are equal in magnitude but opposite in direction. So they can cancel each other. Only the force left on this loop, that is the F1, and it is active to the left. The case for it, to force to right left. But you have to keep this coil move towards right with the velocity v. How is it possible? We apply the external force on this loop of same magnitude but opposite direction. तेवढ्याच मॅग्नेट्यूडचा फोर्स तुम्ही आता एक्सटर्नली म्हणजे तुमच्या हाताच्या साईडने अप्लाय करणार. मॅग्नेट्यूड सेम असणार आहे परंतु त्याची डिरेक्शन कुठे असणार आहे त्याच्या अपोजिट असणार आहे. When you do this, at that time this coil is moved towards right with the velocity v. With the velocity v. So F is equal to F means the force acting towards right. That is nothing but equal to F, but in opposite direction. So F is equal to minus F1. Minus sign indicates that these are in opposite direction. Next one. What is the magnitude of force acting on the segment that is the AD? यास AD एवढ्या या सेगमेंट वरती जो फोर्स F1 ऍक्ट होतो त्याचा मॅग्निट्यूड कसं करणार? Again you know the formula. The force acting on the current carrying conductor is calculated by using the formula that is F1 is equal to I NV sin theta. I NV sin theta. What is sin theta? That is the angle between L and B. आता हा कंडक्टर असतो. B कसा आहे? या पद्धतीने. B इनवर्ड आहे ना? या दोन्ही मधला अँगल किती असणार आहे? दॅट इज द 90 डिग्री and sin 90 is 1. So the force F1 acting here, that is F1 is equal to I NV sin theta. I NV sin 90 is 1. I means that is the current flowing to that element of to that conductor length and magnetic field in which that conductor is placed. So finally we get I and B. This is the force acting. This is the force acting. That is F1. And what is F? This. Of the same magnitude. Look at this one. That is the equation number 5. Now from equation 4 and 5. From equation 4 and 5. What do you write? Equation number 4 and 5. It means only put the value of I from equation 4 in equation 5. We get F and F1 both are same. That is equal to I and B. That is equal to put the value of I. B L B upon R. This and B as it. Here it is the length is denoted by capital L. Okay. B square L square V upon R. That is the equation number 6. From equation 1 and 6, the rate of doing mechanical work. The rate of doing mechanical work. From equation 1 and 6, where is the equation number 1? Here. What is this? It is nothing but the rate of mechanical work. Yeah, आपला साइन फोर्स अप्लाई करता हो तुम्ही. This is the mechanical work. This is the rate of doing mechanical work. So that is P is equal to F dot V. Here we calculate the value of F. Put that value of F here. Dot V. So finally, V into V, that is V square. B square L square B square upon R called as equation number 7. Got up to this point. इथपर्यंत काय मिळालं तुम्हाला? जे मेकॅनिकल वर्क तुम्ही काय करणार आहे, आपलं मेकॅनिकल वर्क करणार आहे या ठिकाणी, तर रेट ऑफ दॅट मेकॅनिकल वर्क इज हियर. आणि जे मेकॅनिकल वर्क केलेलं आहे त्याचा परिणाम काय झालेला आहे? द EMF इज इंड्यूस हियर and due to that induced current is flowing. Suppose the current I is flowing here. The current I is flowing in the closed circuit. The rate of production of heat energy or the rate of electrical work done. हे मेकॅनिकल वर्क झालं, त्याचं रूपांतर कशामध्ये झालं? इलेक्ट्रिकल मध्ये झालं. हे रेट ऑफ मेकॅनिकल वर्क आहे. What is the rate of electrical work? And that electrical work gets converted into heat. You know, where the current is flowing, that wire gets heated. So the rate of production of heat, that is P is equal to, how you calculate? That is equal to I square R. I square R. Heat कसा काढणार तुम्ही? That is P is equal to I square R. Now put the value of I from equation 4. B L V upon R. इथं I square आहे म्हणून त्याचा स्क्वेअर R as it is. Take the square out of this. या R square याचा स्क्वेअर घेतल्यानंतर R square बरोबर हा R कॅन्सल होणार आहे. फायनली we get B square L square B square upon R. That is the equation number 8. Now this equation 7 and 8. Compare these two equations. These two equations is very important. In the equation number 7, This is the rate of mechanical work done. जे एक्सटर्नल फोर्स अप्लाय करून जे मेकॅनिकल वर्क करता तुम्ही त्या वर्कचा रेट आणि त्याचा परिणाम काय झाला इंड्यूस करंट जनरेट झाला. सो इक्वेशन नंबर 8 gives us the rate of electrical work done. The electrical work done. Both are same. Equation 7 and equation 8 same. So here the mechanical work which is done on the loop due to that induction is produced, and with the help of that induction, that energy, that mechanical energy gets converted into heat energy. With the help of that induction gets converted into heat energy in that way. This is the induction. And with the help of that induction, the energy gets transferred in that loop in the form of heat. Got this point clear? This article is very, very important for the board exam for 3 marks. Okay? Now you have to study the next one important point. Okay. Now you have to study the next article, that is the eddy current, or eddy is also called as the Foucault current because it is detected first by the scientist Foucault, so it is called as the Foucault current. Again, this is very interesting and very important article. So what is the eddy current? Before to see the definition, here it is the one plate of metal. There will be the one plate of metal. Now, the main difference is that in the previous article or up to this, we consider the loop and plate are different. There will be the one loop of the conducting wire. It means the middle portion is empty. But now we consider the plate of metal. Metalची प्लेटच आपण consider केली आहे. म्हणजे इथं मध्ये सुद्धा काही काय असणार आहे प्लेट. that is the plate of metal. This middle portion is not empty now. That is kept in the magnetic field. Some part or 50% part of that metal plate is kept in this magnetic field that is shown here. Again, the magnetic field is perpendicular to the blackboard and inside the blackboard or inside the plane of the figure. या फिगरच्या प्लेनला ते मॅग्नेटिक फील्ड कसं असणार आहे परपेंडिक्युलर असतं. आता हे बऱ्याच वेळेस समजून झालं आहे. Now, when you pull this metal plate towards right, it means outside the magnetic field. ही प्लेट जर तुम्ही इकडे पुल करण्याचा प्रयत्न केला किंवा पुल केली, the magnetic flux passing through this plate goes on changing. It goes on decreasing, increase or decrease. The change is important here. So when this plate is pulled towards right, the magnetic flux passing or related with this plate goes on changing, and again according to Faraday's law, the EMF is induced in that plate, and due to that induced EMF, the induced current is generated here. But the induced current which is generated in this plate now, it is different. See, if you consider the loop, the induced EMF is generated, and due to that induced EMF, the induced current is having the path of the current. But here we consider not loop. Here we consider the plate. It means this electron here also. आतापर्यंत जर बघितलं तर ते इलेक्ट्रॉन पुढे होते. So the current is flowing here. But now we consider the plate, this electron here also in the middle, in that plate. So the induced current is generated in this plate. It means the electron of the metal plate, the electrons of that metal plate now start to flow in the circular orbit. The electron the plate मध्ये इलेक्ट्रॉन आता काय होणार आहे सर्क्युलर ऑर्बिट मध्ये रिव्हॉल्व व्हायला सुरुवात होणार आहे ऑफ डिफरंट ऑर्बिट and the motion of the electron is called as the current. So this electron is revolved in a circular orbit. So circular current is generated here. That circular current is generated here, and that circular current is called as eddy current because the circular induced current which is generated in this metal block or metal plate, it is similar to the eddies in the water. पाण्यामध्ये भोवरा जो तयार होतो तो तुम्ही प्रत्येकाने बघितलेला आहे. So the current which is generated here, it is same as the eddies in the water, and so the name of this, that is the eddy current. Now see the definition. The circulating current induced in a metal block or metal plate, when that coil kept in a changing magnetic field, when that coil is placed or moved in a changing magnetic field, ती जी मेटलची प्लेट असणार आहे ती मेटलची प्लेट चेंजिंग मॅग्नेटिक फील्ड मध्ये ठेवा किंवा त्या चेंजिंग मॅग्नेटिक फील्ड मध्ये मूव्ह करा, ठेवा किंवा मूव्ह करा. Anyway, at that time the circular current is generated in that metal plate or metal block, and that circular current is called as the eddy current. Got it? Now see, you pull this coil towards right, it means mechanical work is done here. Due to that mechanical work, the induction takes place, and in the previous article you have seen that induction is responsible to transfer that mechanical work or mechanical energy in the form of heat energy here in this plate. It gets well understood with the help of this second layer. Suppose that plate is pivoted here. म्हणजे कसं असणार आहे बघा, समजा ही प्लेट आहे आणि ती इथे पिव्होट केली. ओके, तर प्लेट इज पिव्होटेड हियर. आता ही प्लेट जी when you release this, pivot केलेली आहे तिथे. When you release it, that plate is moved forward and back in this magnetic field which is perpendicular to the black hole. Got it? When this plate is moved towards this side, again it comes to this, again goes in the forward direction, comes in the backward direction. Every time or every swing, when the coil is enters in the magnetic field, the EMF is generated here, and that EMF opposes which produces the magnetic flux त्याला तयार करते. तर तिथे जे EMF तयार होणार आहे ते त्याला काय करणार आहे, अपोज करणार. So when that metal plate is enters in the magnetic field or leaves the magnetic field, at that time, that mechanical energy is, due to that mechanical energy, it gets converted into induction, and finally it gets converted into heat. So by taking the number of swing, finally there is no mechanical energy in this plate, because every time the induction which is produced here, that opposes, and finally the mechanical energy in this plate is gets vanishes. So at the last, that plate does not move like the pendulum, it remains at the rest position. And so the mechanical energy is gets converted into heat energy here. So from this we get the idea that when the circular current is generated in the metal plate or metal block, at that time the heat energy is produced. Eddy current gives the heat energy. So how that heat energy is reduced, which is produced in the metal block, See here, this is the metal plate, and if you cut this metal plate in this way, this plate, when you cut in this way, at that time, the area of the coil is decreased. And you know, phi is equal to P dot A, that is equal to B Lx. एरिया कट केल्यामुळे काय झालं, एरिया कमी झाला. एरिया कमी झाला म्हणजे मॅग्नेटिक फ्लक्स त्या कॉइल्सशी रिलेटेड असलेला कमी झाला. ॲज द मॅग्नेटिक फ्लक्स इज रिड्यूस, सो द सर्क्युलर करंट which is generated here, that eddy current is gets reduced, so heat get reduced, because when the eddy current is produced, heat is produced. Okay, कॉइल या पद्धतीने कट केल्यानंतर त्याचा एरिया कमी झाला म्हणजे मॅग्नेटिक फ्लक्स कमी झाला. मॅग्नेटिक फ्लक्स कमी झाला म्हणजे eddy current कमी झाला. As the eddy current is decreases, the heat is produced in that coil is also decreases. This is a very important concept. When the eddy current is flowing, the heat is produced, and we take here the benefit of this property. When the eddy current is produced, the large heat is produced. We take the benefit of it. So there are many applications of the eddy current. In the previous year textbook, these eddy current application of the eddy current are given. In current textbook, these applications is not given there. But even though, see, the first application, that is the deadbeat galvanometer. You know the galvanometer. In that galvanometer, the eddy current is used. Second one, that is the speedometer. If you take any vehicle, that is a motorcycle, that is bike or four-wheeler, the speedometer is there, and that speedometer works on the principle of eddy current. Next one, that is the induction furnace. Induction furnace, when you keep the material in that induction furnace, due to that heat in that induction furnace, metal gets melt. So in that induction furnace, eddy current is used. These are the important application of the eddy current. Remember only this application. Okay, you got this thing. In today's article, we will stop here. The remaining parts of this chapter we will continue on next lecture. Thank you.